Hi everyone, it's Mrs. Martello. We're going to do some monitoring progress questions from 8.4 to get some more practice. I'm getting these questions from the textbook, section 8.4. I'm on page 442, so if you want to pull up your online textbook and follow along, that would be a good idea. So first, I just want to bring your attention to some notes that I wrote here. If you want to pause this video and copy down these notes, that would also be a great idea and a good reference for you. So we're talking about quadratic functions in vertex form. Here's the equation for vertex form. Y equals a times the quantity of x minus h squared plus k. So this form is a really nice form because I'm really able to see the vertex and the axis of symmetry just by looking at the form, which is really nice. The axis of symmetry in our equation is the x equals h. The h is the number that comes after the minus sign here. So remember that the minus is part of the formula, and think about if we wanted to make this quantity equal to 0, I would add the h to both sides and I would get x equals h. So if you're looking at the equation, remember that the value of h that you really want is the opposite of what you see because you have to solve the equation. So I'm just going to write myself a note here that the h is the number after the minus. Or in other words, it's the opposite sign of what you see. Okay, so just be careful with that. That's something that people tend to mix up often. And then when we're trying to find our vertex, we're going to put the h and the k together, and that's going to form our ordered pair for our vertex. So the h comes from in the parentheses, and the k is the constant being added after the parentheses. All right, so that's what we're going to use to graph our function. We find those values, we make a t-table, plot those points, and draw our graph. The next thing we can do is we can compare our graph to the parent function, which is f of x equals x squared. So this is just a regular parabola where no transformations have happened. It's a regular U-shaped graph. But once I start adding in this a, this h, and the k, the transformations start to happen. So the a value tells us a number of things. If our a value is negative, that means that our graph is going to have a reflection over the x-axis, and our graph is going to be a downward facing parabola. It's going to point down. But if our a is positive, then it's just going to point up like a regular parabola. The second thing we can talk about for a is the value of a. If a is greater than 1, that means it's going to be a vertical stretch by a factor of a. And if a is between 0 and 1, then that's going to be a vertical shrink by a factor of a. So when you're doing this, remember if there's a negative, you're kind of ignoring the negative sign. The negative is only for the first part to tell you about the reflection. The next part is really kind of like the absolute value of a, just forgetting about that negative sign. So bigger than 1, it's a stretch. Between 0 and 1, it's a shrink. Next, we can talk about our h and k, and both of these are translations. It makes the graph slide left or right or up or down. So if we have an h value here, it's going to cause a horizontal translation. It'll be left if it's a negative h, or right if it's a positive h. But be careful, remember that this h is the tricky one, what we set up here, that the h is the number after the minus, or you can think of it as the opposite of what you see here. So just be careful, especially when you're thinking about positive or negative. And then finally, k tells us about the vertical translation, and if it's up, where that means the k is positive, if it's down, the k is negative, and the k value is what you see here. No tricks about the k. All right, so we're going to take a look at monitoring progress number 5, and this just follows along from the second page in this section. It follows along like example 2. So if you want to take a look at example 2, that might be a good idea. And I'm getting these questions from down here, monitoring progress number 5. So here's our equation, h of x equals negative, or the opposite of x minus 2 squared. So I already have that written down here on my paper, and I'm going to get it ready to graph and then compare this graph to our parent function. So the first thing that I want to do here is I want to identify the axis of symmetry. So I'm going to write AOS for axis of symmetry. And remember, our axis of symmetry is just the equation x equals h. So let's look at our equation that we have over here. Our h value is this value right here inside of the parentheses, but be careful, it's the number after the minus sign. So it's really a positive 2, or you can think of it as the opposite of what you see here. So our equation for this one is going to be x equals 2. That's our axis of symmetry. Next up, we're going to find the vertex of our parabola. And remember, the vertex is just the ordered pair h, comma, k. So we have our h already. I know my h is 2, so I can already write the x value of my vertex. Now I need the k. Remember that the k value is the number that should be added after the parentheses here. So since there's nothing being added, technically that means there's really a plus 0 at the end. So that means our k value is 0. So that means our vertex is going to be the point 2, 0. Okay, now we're ready to make our graph. To make our graph, we're going to make a t-table, and then we can draw our graph on graph paper. So I'm going to go over here to my graph paper, and I already have the equation written down here. Now, when I do this, I'm going to make a t-table for my x and y values. So let's do our x and y values. And when you make your t-table, you can have anywhere from 3 to 5 points, whatever you think is most helpful. I personally like to do 5 points just so I can see more of the parabola, but if you only want to do 3 points, that's all you really need to draw a curve. When I do this, I want to make sure that I put the vertex in the middle of my t-table. So I know that my vertex is the point 2, 0. That's going to go in the middle of my t-table here, 2, 0. I'm going to go 2 numbers down and 2 numbers up for my x's. So this is going to be 1 and 0, and then 3 and 4. And now I need to find these y values. So to find the y values, I can take the x's, plug them in here one at a time, and then write down the answer that I get. So if I plug in 0, 0 minus 2 is negative 2, squared is 4, and then the opposite would be negative 4. I can keep going, plug in 1. 1 minus 2 is negative 1, squared is positive 1, the opposite is negative 1. Okay, and then I know that because our graph is symmetric, these numbers on this side have to be the same. So this is going to be a negative 1, and this is going to be a negative 4. I can also get these values from my graphing calculator, so I'm just going to show you how to do this. If you want to grab your graphing calculator, that would be a good idea too, so you can do it along with me. We're going to go to y equals, and let's type in the equation just like how it looks here. The opposite of the quantity, x minus 2. Make sure you close your parentheses, and then squared. Remember, to get to the table, you do second table. A button up the graph key above the graph says table. Okay, and then you can see here in my t-table, from 0, I get negative 4, 1, I get negative 1, 2 is 0, 3 is negative 1, and 4 is negative 4. This is the fastest way to get the numbers for your t-table, and you can use your calculator, so you might as well utilize it. All right, so now we are ready to make our graph. I'm going to draw my coordinate plane here. Okay, let's start plotting our points. Our first point is the point 0, negative 4. Then we have the point 1, negative 1. Then the point 2, 0, 3, negative 1, and 4, negative 4. And then here's our parabola, just like this, nice U shape. Okay, that's the first part of this question, is to make the graph. Now the second part of this question, just to go back up here, it says to compare the graph to the graph of the parent function. I'm going to do that on my piece of paper here, my lined paper, so I can make it look nice here. All right, so first what we're going to do when we compare the graph is we want to talk about each of the values, the A, the H, and the K. So first, let's talk about the A value. So since our a value here, remember that the a is the number in front of the parentheses. The number in front of here technically is a -1. So since our a value is a negative number, remember that means that there's going to be a reflection over the x-axis. Next thing I can talk about is the value of a. Well, since a is 1, again, I'm forgetting about this negative sign. Since the a value is 1, that means it's not going to change size. Anything times 1 is going to stay the same. There's no stretch or shrink with this. So I don't actually need to say anything about the a value because there's no stretching and there's no shrinking. If this number was bigger than 1, that would be a vertical stretch. And if this number was between 0 and 1, it would be a vertical shrink. Okay, next up, let's talk about our h value. Remember, our h is a +2. H stands for a horizontal translation. So this is a horizontal translation. And since it's a +2, we're going to the right 2 units. Lastly, let's talk about our k value. The k value is 0. So since our k value is 0, that means that there is no vertical translation. And I don't even need to say anything about that because nothing is changing. If the k value here was a positive number, then it would be a vertical translation up, however many this is. And if it was a negative number, then it would be going down, vertical translation down. So I don't actually have to say anything about this k. And that's it. That's monitoring progress number 5. Next up, we're going to look at monitoring progress number 7. I'm going to go to the next page in the textbook so that you can follow along. Okay, and this problem follows along with example 3. So if you want to take a second, look over example 3, but it's basically everything that we talked about. This one is going to have a k. Okay, we are doing monitoring progress number 7. Let's write down the equation first. So we have h of x equals 1/2 times the quantity of x plus 4 squared minus 2. All right, so the directions are the same. We're going to graph the function, then we'll compare the graph to the graph of the parent function. So our first step is let's find the axis of symmetry and the vertex. So over here, I'm going to write axis of symmetry. So for our axis of symmetry, we want x equals the h value. Okay, in our equation, our h value is in the parentheses after the x, but be careful, it should be really after a minus sign. This is a plus, so it's really the opposite of what I see here. It's really a -4. So x equals -4 is our axis of symmetry. Okay, next up, we're going to talk about our vertex. The vertex is our ordered pair, h comma k. I already know my h is -4. I can see here that my k is -2. So let's write it as an ordered pair. That's going to be the point -4, -2. Okay, now that I know these two values, I can go ahead and make my graph. So let me go over to my graph paper. I'll make my t-table, and then I can make my parabola. So for number 7, h of x equals 1/2 times x plus 4 squared minus 2. And I'm going to make my t-table just like how I did before. I'm going to put the vertex in the middle. So my vertex is -4, -2. And I'm going to go and figure out what numbers I'm going to put here. Now I could go by ones, and that would be totally fine, but I might get a fraction here. Why don't I look at my t-table in my graphing calculator before I decide what I want to go by? So let's go into our graphing calculator. We're going to go into y equals. Let's type in our equation. I have 1/2 times the quantity of x plus 4 squared, and then minus 2. Let's do second table. So you can see here that every other number is a decimal because of this 1/2 in front of here. So I think I'm going to go by 2's because of that. So I'm gonna go down 2, so -6, -8, and up to -2, 0. Let's start filling in our numbers here. -8 is 6, -6 is 0, -4 is -2. I already have that, so that's a nice way to check. -2 is 0, and then 0 is 6. Remember that these y's should always be symmetric. So if you get anything that's not symmetric, then you know something went wrong. These two should be the same, these two should be the same, and the vertex is in the middle. Okay, I'm ready to make my graph. So let's go make my graph here, and I think I'm gonna go more over to the left on this one. And I'm gonna still go by ones just because it's not that big of a number to go by. X and Y. So I'm focusing more on quadrant 2 here. Let's start plotting our points. -8, 6. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Let's keep going. -6, 0. 1, 2, 3, 4, 5, 6. And then -4, -2. 1, 2, 3, 4, down 2. -2, 0. And then 0, 6. And there's our parabola just like this. Okay, so even just in comparing these two parabolas, we can definitely see things that are different. The first one is pointing down, this one is pointing up. The first one was not stretched or shrunk. Look at how wide this second one is. This one is definitely wider. And then look at where the vertex was. This one, the vertex only moved right 2. Now the vertex is left and down. So we're gonna talk about all those transformations in our next step. So now let's compare this graph to the graph of the parent function. And a good way to check to make sure you graphed it correctly, let's go back in your graphing calculator and just hit graph. And your graph should match up with what you see here, and ours does. Okay, so let's finish this question up. We're going to describe the transformation. Let's first talk about our A value. So since our A value is 1/2, it's positive. So that means there's no reflection. But since our A value is 1/2, that's gonna cause our graph to be a vertical shrink by a factor of 1/2. And that's why our graph was so wide, because it's being shrunk vertically. It's getting squished down to the x-axis. Next up, we're gonna talk about our H value. Remember, our H value is -4. It's the opposite of what you see here. That tricky H, just be careful. So if our H is a -4, H stands for a horizontal translation. And if it's negative, we're gonna go to the left 4 units. Lastly is our K value. Our K value is -2. K is for the vertical translation. And because it's negative, we're gonna go down 2 units. And after you write this out, just double check, does this match up with what you drew in your graph here? Yeah, it's definitely wider. Our graph is pointing up. Look at where the vertex is. It's to the left 4 and down 2. So it does match up. It's a good way to check. All right, I hope you found that this was helpful, and please use this when you're doing the review assignment for section 8.4 for our test that's coming up.